in this part we'll be looking at polynomials. The first goal at hand will be to know the vocabulary for polynomials. But first, let me introduce by saying that you will be introduced to polynomials. Okay, we will classify them into groups, define their degrees or degree, and show how to evaluate them at specific values of their variables. So those are the four main points we'll be looking at polynomials. So to begin with, we're going to be starting by knowing the vocabulary for polynomials. It's very important for us to know their vocabulary. So know the vocabulary. Why should we know vocabulary for polynomials? Because if we don't know what we're talking about, then that means that we will not know what we're looking for or what we are being told. So we'll be looking at terms first of all. Recall first of all that a term is a number or a product of a number and one or more variables which may be raised to powers. So I'm going to be giving you some terms right now. So this is a term, 3x, that's a term, a number and a variable, they're both multiplied. The power of x is the power of 1. Negative 4y squared, again a next term, 1/2 a squared b cubed. T by itself, there's a value of 1 in front, and 25. Okay, those are all terms there. Now the numerical coefficient 3, -4, 1/2, 1, or simply coefficients of the first 4, 1, 2, 3, 4, okay, of these terms are 3, -4, 1/2, and 1. Those are the numerical coefficients. Because 25 by itself can also be written as 25x to the 0 power, 25 is considered to be the numerical coefficient of the term 25. Let's see. So let's identify the numerical coefficients here. Numerical coefficients of the first 4 terms are 3, -4, 1/2, and 1. Okay, those are the numerical coefficients, or simply coefficients, of the first 4 terms. Okay, now because 25 can also be written as 25, could be 25x to the 0 power or a to the 0 power. Okay, then 25 is considered to be the numerical coefficient of the term 25. Okay, so that's what we mean by numerical coefficients and terms. So in short words, this is definition for a polynomial. Definition for this: a polynomial is a term, just as this one's here is a term, or a sum of terms, as you will see in a little while. I will explain it much more in detail, in which all variables have whole number exponent. Very important, understand that part, of whole number exponent. No variable, and this is by law, no variable appears in a denominator. If you notice, there's no variable appearing below a whole number. They are all like big values. So a polynomial is a term or a sum of terms, okay, in which all variables have whole number exponent. Notice them: power of 1, 2, 2, 3, and this is a 1. No variable appears in a denominator. Now let's get some example of polynomials now. Here are some examples. Remember, by the definition or a sum of terms, we can see 3x plus 2, 4y squared minus 2y minus 3, negative 8y squared, a cubed plus 3a squared b plus 3ab squared plus b cubed to the third power. Okay, so 3x plus 2 has two terms. This has two terms. Let me do this in red. Two terms. What are they? It has two terms. The first term is 3x and the second term is 2. So this is the first term, this is the second term. We say it is a polynomial in one variable because there is only one variable, x. So this is a polynomial in one variable. That's a polynomial in one variable. Okay, so those are key points. Now, a single number is called a constant, and so its last term 2. So this is a constant. This is the constant here, and it's called a constant term. So this is one variable, and 2 is called a constant. So let's break this one here apart. 3x plus 2 is considered a polynomial that has two terms. Which two terms? 3x and 2. Okay, we say that it is a polynomial with one variable because there's only one variable here, and a number is called a constant, which is this 2 here, and so it is the last term in this particular polynomial. So 2 is considered a constant term because it just added on to the equation. Okay, now let's go to the next polynomial that we had here. Our next polynomial is 4y squared minus 2y minus 3. This can be written as, okay, we can break this up and we could say this to be 4y squared plus a negative 2y plus a negative 3. We can write it down and it means the same thing. It is the sum of three terms. Notice the sum of three terms. 1, 2, 3. Okay, so the sum of three terms. Now, it is written in decreasing, descending, or decreasing powers. Notice the decreasing power. The power of y here is 2. The power of y here is 1. What's the power of y here? Well, we don't see any y here, so therefore, and the only way y can exist here is that if we say y to the 0 power. So this polynomial here, I will write it here in the words. It is written in descending or decreasing powers of y, and if this was x, it would be decreasing powers of x, because, and take note of it, because on y decrease from left to right. From left to right it decreases. This is higher, in other words. Okay, so that's our polynomial for that one there. So let's go back again. This is a polynomial which is written in decreasing or descending powers. This is a polynomial with 3 terms that can be written as the sum of 3 terms. Okay, that's basically it. Let's look at the next polynomial. Negative 8y xy squared is a polynomial with 1 term. Polynomial with 1 term. Okay, we say that it is a polynomial in 2 variables. Polynomial in 2 variables, and let's see why. We have 2 variables, x and y. That's why we call it polynomial in 2 variables. Okay, that's basically it for this one here. A polynomial with 1 term here, and a polynomial in 2 variables. That there are 2 variables compared to when we break it down in this way. Okay, now let's go to the next one. Our next polynomial was a cubed plus 3a squared b plus 3ab squared plus b cubed. The ones who are very observative, you will notice the way the powers of the a's decrease and the powers of the b's increase. Okay, so this is written in descending powers of a and ascending powers of b. So let me write down that. Written in descending powers of a and written in ascending powers of b, because they are increasing. So that's basically for the polynomials. All right, now caution. Now, let me write this down, because this will count us back. No, so these are caution we need to take. If we have an expression 2x cubed minus 3x to the negative 2 plus 5, this is not a polynomial. Not a polynomial. After we have gone through the description just now, this cannot be a polynomial, because the second term, notice it good, the second term contains variable or a variable with an exponent that is not a whole number. Okay, the second is not a whole number. Similarly, y squared minus 7 over y is also not a polynomial. Okay, now let's understand why. Because 7 over y has a variable in the denominator. So these are the cautions you need to take. Notice this one here, the second term contains a variable with an exponent that is not a whole number, negative. So it's not a whole number, it is an integer, not a whole number. This one here is not a polynomial because it has a variable as a denominator. Okay, so that cannot be a polynomial for that one there. Okay, now let's try a few examples. So this is the way I'm gonna word the questions to you guys. I'm gonna tell you, determine, let me put that in blue, determine whether each expression is a polynomial. We have just gone through the description of polynomials. Okay, so I'm going to give you an example. We have x squared plus 2x plus 1. Given that information, is that a polynomial? Well, first of all, we need to have a method to solve it, or a strategy. We will know that the exponents on the variable basis, the exponents 2, 1, 0 basis, will also identify each denominator. Right? Why? The expression in a polynomial, when all the variables have whole number exponents, no variable appears in a denominator of a fraction. Okay, so let me write the strategy. This will be your strategy that you are going to use to solve these questions here. If your strategy will be, note the exponents on the variable basis. Also identify each denominator. That will be your strategy. Why are we going to do this? Because the expression is a polynomial. This one here is a polynomial when all the variables, okay, have a whole number. Very important, a whole number exponent. So we don't want to have any exponent as negative, and no variable appears in a denominator of a fraction. So if there were to be a fraction in this particular expression, then the polynomial, well, that fraction cannot have a variable at the bottom. Therefore we can say that this is a polynomial. So polynomial, yes. Okay, let's go to another one. B, 3a negative 1 minus 2a minus 3. This here is not a polynomial. We write why. Why? Not a polynomial. Let's see why. In the first term, the exponent on the variable, is that a whole number? No. So therefore is not a whole number, and because it's not a whole number, then it does not fit the description of being a polynomial. Okay, go to our next example. C, 1/2 x cubed minus 2.3x. okay, in this case this is not times unless you were told about it. This is a polynomial, mind you, with this first part it might distract you. Okay, it's a polynomial, right? Because it can be written as the sum 1/2 x cubed plus negative 2.3 x. It can be written as a sum. Okay, so it is a polynomial. All right, go to a fourth one. If I give you p plus 3 over p minus 1, you'll get to see problems like this soon. This is not a polynomial. And why this is not a polynomial? Because for a polynomial, because a polynomial the variables in the polynomial, in other words, variables cannot be in the denominator of a fraction. They cannot be in the denominator of a fraction, so we have it here, so that cannot be a polynomial. All right, so that is how we can classify polynomials there in that part there, if it's a polynomial or not a polynomial. All right, now here comes the next part to this. Into the next piece here, and we come to the next part. We're still on classifying polynomial. So a polynomial, so let me write this note here. A polynomial, right, with one term is called a monomial, and by the part mono means one, you can say a polynomial with two terms is called a binomial. A polynomial with three terms is called a trinomial. Notice how they keep increasing. All right, so from examples, so let me put a little table here. We're gonna have monomials, binomial, and trinomial. Okay, down I'm going to list some examples of monomials, binomial, and trinomial. Okay, so this is a monomial: negative 6x, 5x squared y, 29. These are three monomials. Binomials now: 3u cubed minus 4u squared, 18a squared b plus 4ab, negative 29z 17 minus 1. This is binomials, two terms, one term. Trinomials now: negative 5t squared plus 4t plus 3, 27 x cubed minus 6x minus 2, a squared plus 2ab plus b squared. These are all trinomials, 3 terms. Okay, so that is what we have there. Alright, so that is how we will be classifying them as binomial and be able to define the trinomials and so forth. So let's go with a few more examples of monomials, binomials, and trinomials. Let's see. If I was to give you a term, you should be able to know if it's a binomial, trinomial, or monomial. So they are all polynomials. Okay. So let me put some other examples. So here are polynomials. So let's say I give you a bunch of polynomials, and let's say one of our first example is 5.2x to the fourth plus 3.1x. What kind of polynomial is it? Is it a monomial, binomial, or trinomial? Well, we can count the number of terms in each polynomial. How many terms do we have here? It has 2 terms, so it must be a binomial. Okay. Next one, B. 7g4 minus 5g cubed minus 2. Binomial, trinomial, or monomial? Well, it has 3 terms, 1, 2, 3. So it must be a trinomial. Now, I give you a next polynomial. That polynomial is negative 5x squared y cubed. Has 1 term only. So it must be a monomial. Okay, so that is what we have there as polynomials and so forth. Now, a tip: recall that terms are separated by positive or negative. Each term here is separated by positive or negative or symbols, and the numerical coefficient is a numerical factor of the term. The numerical coefficient is the factor here, which we have at the front. All right. Okay, so now let's start to classify them with their degrees. You just have to remember some very basic rules. So if I give you a monomial, and that monomial have 7x to the 6, this is a monomial of degree 6. Why we call it a degree 6? Because the variable here, x, occurs as a factor 6 times. So this is raised to the power of 6. Our next monomial, 3x to the third y fourth, is a monomial of 7 degree. They're not the same variables, but it is a monomial of 7 degree, because if you notice their powers can add up. However, I'm not saying that you will add their powers to multiply them. Okay, it's just to get to what degree they belong. Okay, now let me give some other examples. 2.7a is a monomial degree 1. Negative 2x cubed is a monomial of degree 3. 47x squared y cubed is a monomial of degree 5. 8 is a monomial of degree 0, because it is 8x to the 0, or whatever letter you want to put to the 0 power. That's why you call that to a degree 0. So by definition, degree of a monomial, so the degree of a monomial, so let me put it here, degree of a monomial goes as follows. If A represents a non-zero constant, the degree of the monomial ax to the n is n. So the power or the degree is that there. The degree of a monomial in several variables is the sum of the exponents on those variables. What does that mean? Well, it means like this: the degree of this one here will be add their powers, you get power of 5. So that's what it means. However, take note, and I will write this in red: caution, you need to be careful with this piece here. Note that the degree of ax to the n is not defined when a equals 0. If this was a 0, it's not defined, since ax to the n would then be 0 when a equals 0. The constant 0 has no defined degree. Okay, now because each term of the polynomial is a monomial, we define the degree of a polynomial by considering the degrees of each of its terms. So the degree now of the polynomial, so we just did of a monomial, so the degree of a polynomial, write the definition of that: degree of a polynomial is determined by the term with the largest degree. Okay, so now let's go into polynomials. We will take some polynomials now and classify them, and to what degree are those polynomials. So let's say, for example, we have x squared plus 2x. This is a polynomial, is a, well, actually is a binomial. You could say, to be more specific, because there are two terms, so is a binomial of degree 2. That's the highest power, because the degree of its first term is 2 and the degree of its second term is less than 2. Let's see. Let's understand this definition again. This is a binomial because there are two terms. Not because there are two terms it means it's a binomial of degree 2. It is a binomial of degree 2 because the degree of its first term, the first term is 2, and the degree of its second term is less than 2. So if you notice, this is a power 2, This power of this one here is less than this one here, so that is of degree 2. All right, now let's go to our next example. 1 plus 3 d to a third minus 3d squared. This is a trinomial, 3 terms, trinomial of degree 3 because the degree of its second term is 3 and the degree of each term of its terms is less than 3. Now if you notice, these are trinomial 3 terms of degree 3 because that is the highest power that we see here, because the degree of its second term doesn't really mean that this second term must be the highest power. This term with the highest power can be on your left hand side, okay, or to your right hand side, doesn't make no difference. And the degree of each of its terms is less than 3, 2, and this is d to the 0 power. Okay, so let's go to our next one. 25y 13 minus 15y 8 z 10 minus 32y 10 z 8 plus 4. This is a polynomial of degree 18. So you can say polynomial of degree 18. Why? Because its second term, not necessarily has to be the second term, and third terms are of degree 18. Its other terms have degrees less than 18. So all of the other terms have degrees less than 18. Notice how do we get 18 here? Are their powers. How do we get 18 here? Are their powers. Doesn't mean that 2 terms must have degree 18. It can be 1 and that is still okay. Alright, so that's for getting those ones there. Now